Greetings and salutations. I'm back down the shed again, and something a little bit different today. I wanted to give a brief overview on electronics. This is no way to be interpreted as expert advice. I'll give you a little bit of background. I learned about electronics in high school. I think I did a semester on it. And that was mostly just the basics, like figuring out a circuit and drilling holes and designing a board and etching and all that type of stuff. But most of my professional expertise was as an electronics assembler, which I did 2005. I did that up until about 2008. Most of my experience is, as I said, assembly, and that's just like basic board population, soldering, a little bit of surface mounting, which I would not recommend doing. But on the whole, I'd say if you're really interested in going into this, do a short course. I am not a programmer. I'm really not that much into Arduinos. I've been experimenting with it a little bit. I'm not that confident in it yet. So an actual Arduino course, this is not. This is just some basic tips on electronics. But I'm going to focus more specifically on tools, because tools is something we can talk about, especially safety around tools. I'll get the important one done out the way. If you want to start building electronics, you're going to need one of these, a soldering iron. Now, I've had this for at least 10-15 years, and can tell you how long old it is. This is a Dick Smith Electronics soldering iron, and I got this way before they stopped actually having electronics. This is just your bog standard soldering iron. This is 25 watt. You can get hotter burning and lower burning ones. It usually depends on your wattage, I believe. Someone's probably going to correct me, but I've got like a 50 watt one which burns a lot hotter. That's good for carving things, and that's not necessarily for soldering things. I recommend buying a holder, particularly one that's got a solder cleaner in it. Very useful. Solder cleaning is by far a thing you need. Basically, your soldering iron is what you're going to be using to not only melt solder, but also is what's going to essentially create the bridge between the contact on the circuit board and the leg or the pin on a component. And you need enough heat to transfer the heat onto the board, the pin, and the solder, and melt the solder. That's the basic fundamentals of a soldering iron. A couple of things. This one actually has a smaller tip than what you can get to. Oh yeah, before I do this, make sure your solder is completely unplugged before you even attempt to touch the metal bit. Now, this has obviously been unplugged for quite a while, and I'm still hesitant to touch it because just the experience. The tips are removable. The one that usually comes with this is this really big chunky one. I'll give you a size comparison. Now, this is going to help you out if you're starting off and you're just blundering your way through a lot of soldering iron. These are going to help you out for more, not necessarily delicate things, but like smaller contacts. Like if you're doing like a lot of chips, they got a lot of tiny contacts. You really don't want to spread the heat out too far, because then the heat will just make the solder go everywhere. So you got to be very particular about that. I prefer a smaller point because that's just how I'm used to working. You can get kits with these together. You can get adjustable soldering irons and all that. I wouldn't bother unless you're really wanting to dive deep into this hobby, but for the most part you can get away with just one of these. Cleaning your soldering tip is almost crucial. You'll probably hear some people go, all you just need is like a sponge with a bit of water on it. I've used them before. I don't recommend them. If you've got nothing else, yes, just get like a scrubbing pad, sponge, and a bit of water. That'll clean your tip. However, that tends to cool down the point of your soldering iron. That's why I would never recommend it. If you can, get one of these brass cleaning tubs. You just got to J-cast on that electronics. They'll point you in the right direction. Now, what these does is essentially the solder will just scrub off. The great thing about this, it cleans it a lot more effectively, and it doesn't cool down the tip. The other point is, people will say you should clean your tip before you put it down. No, do not do that. They are wrong and they are evil. They can potentially destroy your soldering iron, or at least your soldering iron tip. It's fine just to leave your tip in the holder while you're not using it. In fact, all the excess solder will probably burn off, but it also, as heat will occur, it will also oxidize the tips. And because you don't want oxidization, that's when you clean it first and then you start applying. They give you plenty of time to work as you're going. So yeah, clean your tip before you work, not afterwards, and you'd be surprised. I cannot stress enough, never ever touch the metal bit while it's plugged in. If you want to test if your soldering iron is at temperature, then grab a bit of solder and just touch it to it, because if it's hot enough, it will melt. It will pretty much just melt immediately. So the last tip when it comes to soldering iron is you've got to be careful when you're soldering a component. Components, for the most part, yeah, they're built to withstand heats, but just not a tremendous amount of it over a long period of time. You essentially are looking at doing this roughly 2 to 3 seconds. So let's do the extremely slow version. So you got a component here, you've put down the heat, put down the solder, you kind of push it in, wait for it to melt, add a little bit of solder to the circuitry and the component, lift off, that's it. But in theory, that's all well and true, but in practice, there's things that can go wrong. Highly recommend you, once it's cleaned, you're about to use it, just quickly add a bit of solder onto the tip. It's all well and good to say this, you got to practice it, because not enough heat, you're not transferring enough heat onto both elements. That's not going to transfer the solder. You're going to end up with a bad connection. Too much heat, you're going to cook your components. You can get away with maybe using some alligator clips to like absorb some of that. That can be finicky. You can add a little bit more solder if you're not too sure, but again, you don't want it to be ballooning. If it's odd shaped, you can sometimes add a bit of heat, but my tip is, if you don't think you've done a good connection, don't immediately try and fix it. Let it cool down for a bit and then reapply and then add a little bit of solder, because the flux in the rosin will help it cure again. And if you're not entirely sure, use a solder sucker, remove it, and then deal with it later. Allow the components time to cool down. You know, only take a few seconds. It's not going to take a lot of minutes, but while you're waiting for one, do another connection. Honestly, it's practice. I'm still not 100% confident sometimes on these things. I will go back and redo them. If the solder has moved on between 2 tracks, yeah, definitely wait for it to cool down, reheat them, and get a bit of solder sucker, whatever. You might get solder in a kit and it'll look something like this. Right, it's all well and good, it's still useful solder. If you want to do a lot of electronics, buy one of these spools. Just ask at JCar, I just want some solder for a soldering thing, and I'll just point you to the generic use ones. What people don't realize is solder is a particular thing. It's not just metal. And there's a reason why this is bendy, is because this actually has a lot of rosin in it. Now, rosin is basically a flux, and the flux is what helps bind the metals together, and it cleans and all sorts of things. I once worked in an electronics area where we just rosined everything, specifically because we're doing wave soldering. The wave solder is just literally a vat of solder, molten solder. Think like molten metal, but just this stuff. If you ever need to remove any solder, like you've accidentally joined over the wrong hole, or you need to remove a plug, you need something like this. This is a solder sucker. Now, it's very simple in usage. You have a plunger, you plunge that down like that, you go over your component, you heat it up, and then you press the button here, and that will suck it up. This is what they mean by suck it up, sunshine. And yes, this is kind of just so much fun to use. Now, if you can afford it, or you are genuinely interested in doing this a bit more than just once or twice, get a metal solder sucker. I've had a plastic one in the past. They jam up far more regularly, they will break down, and this is just a lot better. So once you've sucked up your solder, then you just push that down, and you push down a little bit further, and that little point comes out, and that's usually where a lot of your solder will just come out with. You've sucked up a lot of solder. If you do need to clean this out properly, then you just need to unscrew the tip, like so. There's a spring in there, and you can pull these apart and clean them more thoroughly, but for the most part, this is just what you need. These metal ones don't tend to jam up as much as the plastic ones in my experience. And you can get a nice brassy one like this. Those are handy. Other tools you'll definitely need, wire cutters. Now, you can just get these from practically anywhere. I mean, I've literally had this for like over 10 years. This is one of the ones I used to use at work. If you're doing a lot of cutting, these will kind of blunt over time, but for the most part, they're still good. Kind of over cutting my boundaries, but spring loaded, they're handy. If you want to add the extra expense, you can get wire strippers. I've never met a wire stripper I've actually liked. Even when you've adjusted them properly, they'll tend to strip out some of the copper, which is dangerous when you've got some really thin copper wires, especially some like specialty wire. And sometimes I'll just use one of these and just gradually go and cut it around, or you can use a pair of scissors. I'd recommend a pair of wire cutters over a pair of scissors any day of the week. Now, speaking of wire, I've got two different ones here. This is just speaker wire. And you can get this practically anywhere. Jaycar sells it, any audio place will sell this, but this is probably generally the wire you'll mostly use. You notice that it has a black strip and a non-black strip. That's so you can know which is your positive and negatives. Most people will use black as the negative, but I've heard weird people say that the black should be the positive, and they're weird. As long as you know what's your positive and what's your negative, regardless of the color, use them. To make these things a little bit easier, universally in electronics, red is a positive and black is a negative. So when you have wire like this is actually a thicker gauge than the speaker wire. As you can see, I use this a lot. I bought like 10 reels of this when Dick Smith's was, finally liquidating all their stock, and like the last Dick Smith's on the planet was selling off all the things. I bought pretty much most of their stuff, and I've gone through most of it. Great stuff. Just to further enforce that, if you get a battery connector, see it's already got the positive and negatives marked. So if you've got a circuit board and it's got a thing there that says 9 volt plus minus, then you know the red goes to plus, black goes to minus, across the board. I mean, literally across the board. Before we go into the boards, just extra tools that you'll find handy. You don't have to use these, but they'll make life so much easier. One of these, I'm not entirely sure what they're called, but just go and say I want one of these little tools that's got like clamps and thingamajigs. I think it's just called a desk mount or something like that. I've got the box. I've had this for so long, I've forgotten what it's called. Now, all these things are adjustable. You've got tightening screws. You can replace these alligator clips with other things if you're so inclined. I find these are incredibly handy. Definitely keep into a well-ventilated room. That's just common sense when you're dealing with something that burns things. However, I would also recommend fan. Now, so good. I mean, fans are, horrible visually on video, and they're probably gonna ruin the audio. Don't blow the fan directly onto the soldering iron. Have it suck away. So point it away, turn it on. What happens is all the fumes will then go push out there and disperse outwards. You don't want to be inhaling too much of this crap. Like practically anything with any prop building and you're dealing with a smoke or a vapor. If you're that paranoid, get a respirator. Just with this type of stuff, you can just get away with a fan. Just a little small fan. You can get these from Jaycar. These are also really good when it's a warm day and you buy the computer. This is USB powered, and it's got a battery in it as well. Yeah, highly recommend one of these. And this one is handy because it also has a light. Now finally, let's quickly go over components. Components are those things that can and will screw you up. Now these may all look the same, but they're actually of different values. And learning how to identify the different values is a little bit tricky, even for someone who's been doing this a while. If you buy one of these kits from like Jaycar or something, they do come with a booklet. In fact, but this is not the full instructions. They're supposed to have a book that comes with this. Found just recently you can actually download the PDF of those books from their website. So I'd highly recommend that. That'd actually give you more instruction on how to make the thing populate and all sorts. But don't throw this book away, because this gives you all your components, and more importantly, tells you what the components are. Now, I'm just going to quickly demonstrate it. See, you've got ones here like brown, black, black, brown, brown. And then you also have one here, which is brown, black, black, red, brown. And I've taken a couple of photos of these. They should be on screen here, which is all well and good. But they have two different values. One of them is 10,000 and the other one is 1,000. There is a system at play. I'm not going to bother trying to explain to you because I'm not entirely sure. You've then got to try and identify what these components are just by looking at them. And from a distance and with under certain lightings, the brown, black, black, red and the brown, black, black, brown, black, black, brown, 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 black, brown, brown. So yeah, I'm just try to grab the brown, black, 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 brown, and I grabbed one with green on. I think I'm missing a couple. Oh well. These two are almost visually identical. If I held these out at a distance here, closer to you but far away from here, there's no real chance I can see what these are. And getting up close, if I am looking for brown, red, red, brown, brown, black, black, red, brown, I see this one. In certain lights, that could look like a red, brown, until I hold it next to this one and go, oh, this is definitely a red, brown. This is the trouble with a lot of these colors, especially on the blue. You got to be careful. And yes, these are all important. There are very good reasons why these are individual ones. The TLDR is that resistances are what change the currents to make things happen. So what I like to do is, if I'm looking for a particular, this can be either way. If I'm looking for a particular one, find out what it is on the board and then put a mark. I use a blue pen for a very good reason. So I'll mark that down and I'll mark down what the resistance is. The board's not going to say red, black, black, red, black, black, red, black, black, red, black, because that's not a real resistor calculation. Brown, green, black, black, brown is 150R. So on the circuit board, I've got to look for 150R, which is right there. Now there's 150R and 150K. Now K isn't just a letter, it means 1000. You even have 1K0, 1K5, 1K2. That means it's 1000, 1002, 1005. 4K7, 4007, 15K, 10K. These are important. Now, you sometimes will get multiple of the same ones, and these are easy because then you just go, oh, that's two of them, that's marked off. Now, the great thing about resistors, after all that aggravation, is that omnidirectional. Or at least, you don't have to worry too much about having one go positive, one go negative, which is brilliant. However, that's where the other components start to become something annoying. A diode essentially looks like a resistor, but it's a black tube with a silver end. Now, you definitely don't want to get these mixed up with resistors. They do go in a direction. Now, if I go to the circuit board, the diode is placed right here. Now, if you look at the diagram, it's got A and K, and it looks like a resistor icon, which is basically a rectangle with two lines. But this is a rectangle with two lines off the side and a line on one of the ends. That tells you visually which end the silver bar needs to go on. Now that is true for lots of other components. These circle ones here, they're for capacitors. They have a plus and a negative because the capacitors have a line on them to indicate the negative. The icon here has a plus sign. You don't align the plus sign with the negative, you go opposite. Now you can use the visual references in the manual, they'll at least help you do that, but you got to remember to try and keep these things in mind so you're not getting the wrong way. If you get these things the wrong way, not only will they not work, things may explode, or at least pop. You've got all these different types of components. I'm not going to run down all of them. This is something you need to kind of look into, but you'll need to follow the diagrams to find out where they go. A lot of components, like the green caps, are also omnidirectional. They don't particularly matter. The instructions will tell you if they do, or the board will tell you if they do. So that's pretty much it. I'd say if you're interested in doing electronics, just start. If you're not confident about populating a board or anything like that, do a short course or find someone who can help you out. Remember, this is different from programming. This is not about designing circuitry, and that's a whole different kettle of fish. And this is not Arduino. Although you might have to buy some boards where you have to assemble Arduino, and some Arduinos you will have to solder things together. This is separate from that. But knowing the basics of this will help you with your Arduino work, especially knowing how to do good soldering. If you've got an old VCR that's completely dead, or even some old computer circuit boards on that, just grab them and study them. And also, if you are so inclined, get a soldering iron, get a solder sucker, or get some solder and practice your soldering techniques on that. It doesn't matter if they're dead or not, you're just practicing the technique. It's a learned skill. And again, never touch the hot metal bits. Solder can spit out, or at least the hot rosin and the solder can spit out. If you're worried about that, wear some gloves. If you got a whole lot of solder on the tip, you can kind of just knock it down onto, always like work on newspaper or like a cutting board or something like that, and don't work on a good desk. If you drop your soldering iron, it can burn things. Yes, be safe, be curious. If you're worried about, again, spitting, wear a pair of goggles. Keep a fan to blow away the fumes. Basic safety stuff. If you enjoyed this video, please share, like, and subscribe. Add some comments down below. If you have any things you want to see me tackle, please let me know. If you've got any tips and hints that I could benefit for myself, definitely let me know about that. If you want me to give a further explanation on anything I've done, again, comment below. I'm trying to keep to a more rigid schedule now that things are starting to get a bit normalized in my life. Planning on doing a Monday and Friday shed video and a Wednesday vlog, but that might change depending if I restart does whatever a spider can or terrible tie-ins or one of the other things I desperately want to get done. If you've seen any other videos and you want to see more of that, comment and let me know. So thanks for watching, and I'll see you later.